Now, we will continue with our program on AI and big data. On this very stage, I have the pleasure to welcome Jonas Andrulis from Aleph Alpha, who will talk about train and trust your parrot, industry examples for the use of generative AI in complex and critical use cases. Jonas Andrulis founded Aleph Alpha in 2019, which is already his third AI startup. And since then, Aleph Alpha has raised a total of 28 million euros from some of Europe's top deep tech investors, with the goal of establishing independent top AI research and run enabling technology for a new kind of AI value creation process. Please welcome Jonas Andrulis.
Thank you. Great to see you. Yeah, we've started training large language models when there wasn't even GPT-3 out. So we're kind of the old school of generative AI, so to speak. So you've kind of all seen those fancy use cases, social media is all over it, a lot of cool like ChatGPT and all other models. But what I want to show you now is like, how can we apply this technology to critical use cases? How can we take responsibility for outcomes? And I think this is somewhat difficult to answer because most questions we are solving in our daily life are not as simple as when were the Spice Girls founded. And this is a simple question, has a simple answer, you can verify it. ChatGPT knows the Spice Girls, as do probably most models, but can we build an industrial revolution by just asking chatbots about general knowledge questions or like writing our homework? Probably not. You may have seen kind of chatbots already succeeding in some rather complex cases, like medical or like business. When you see these kind of results, always take them with a grain of salt because these are benchmarks and tests built for humans. And the fact that AI can solve them is very much noteworthy, but does not mean that the AI is at the same level of capability than a human doctor or a human business expert. Nevertheless, it was quite remarkable that in the Hopkins study on medical, not only were the answers given by the chatbot ranked in terms of quality much better than what the human was able to provide, also empathy, right? They also beat humans on empathy, which if you've been in a hospital recently, maybe you're not surprised. Again, right, this does not mean that the AI actually has empathy, but it shows that pretty much all standard value chains, all kind of knowledge work that we're doing will be transformed. And will be transformed and eventually will probably result in a far better experience for everyone involved. Doctors having more time and patients being kind of interacted with more empathy, although the computer doesn't really have empathy, but from the perspective of a student or a patient, you probably don't care too much. Okay, what does that mean for trust and truth, right? So we've seen that the tests come out pretty good. So can we just connect our AI to all critical use cases and off we go and off to the beer garden? It's not that easy, and this is Perplexity, pretty cool app. So if you haven't tried it, give it a try. Where you can kind of interact with like a chatbot-like interface. It's like a mixture of web search and a chatbot. And of course, as any proper narcissist would do, I'm asking Perplexity about my own biggest achievements and comes up with 3 bullet points. The first 2 are pretty much correct. And they provide the sources here. And the third one says that I am a chairman of Mensa International, consultant to GE and Warner Brothers, and member of the IEEE and IET. And I can assure you none of that is correct. But it has a source, right? So it has to be correct. Right? So this gives us extra certainty. It's not just like a ChatGPT answer. It has a source. So let's look at that source. This is the web page that is linked behind the source. It's kind of rather big web page, has a lot of information about language models. Okay, this does not help us immediately, so let's just search for my name. And when you do that, you see there's a quote here by me. Large language models can solve every problem that can be expressed with language. This still doesn't help me that much, but if I scroll down pages and pages, this is the author of that page, and the author is a chairman of Mensa International, consultant to GE. and so on, right? So this is like not even close to my name. And this is just one example, right? I'm not bashing Perplexity. This is like generally what we see in the systems, that they sometimes misunderstand, URLs are sometimes misleading, and they are not super robust at reasoning. And I have my favorite example from ChatGPT for that. If you kind of know action movies from a few decades ago, you may remember that puzzle, a 3 liters and an 8 liter jug, and I want to measure 5 liters of liquid. I can fill the 8 liter jug. Now I can pour the contents of the 8 liter jug into the 3 liter jug, leaving me 5 liters remaining. I can empty the 3 liter jug. So far so good. And then pour the 5 liters of liquid from the 3 liter jug back into the 3 liter jug. The 3 liter jug now contains 5 liters of liquid. So why I like this example is it shows how these systems learn. They learn patterns. So the overall pattern of how to solve that problem is learned correctly. You kind of have different jugs and you pour liquids from one in another and you empty them. But the reasoning capability that a human has is not present. A human that really understood this problem would have never said the 3 liter jug now contains 5 liters of liquid. So I think this is what we have to keep in mind, where there, and like, I think I've recently checked the same thing with ChatGPT. It now solves it perfectly. So these parrots are getting better and better. We're training them ever more complex patterns and knowledge, and they're getting better. But it's basically just parrots that are learning ever more complex patterns, and they're not learning reasoning. And then I'm happy to chat about the philosophy of emergence of reasoning when we just kind of scale this up tons, which is definitely not impossible. It's possible that this will happen, but we are far from that as now. So we've trained these systems complex patterns. How can we take responsibility? Do we, right? Because, I mean, something like that, we don't want to let that loose on critical use cases. And one of the things that kind of came out of our research that is a major step in the right direction is our explainability. There's a paper out there, so the method is fully open source. And here's an example how that works. This is our playground, so this is kind of interacting with the naked language model. And I'm asking a question about like the old kind of question on 2 cars driving towards one another. How long does it take until they reach each other? And on the bottom, you see the output of the language model. It does some intermediate steps because it has learned that kind of pattern on how to solve that problem, and then uses the intermediate results to come up with the right conclusion. And what you can do now with this explainability is for every single token or every single word in our output, we can see where the information is coming from. So we see the calculation on the speed of the second car, and then we see here, this comes from the very top, and this is an intermediate result that was just been calculated. So we can trace the flow of knowledge from original sources, from intermediate thinking steps, from like language chain kind of technology. This does not guarantee that's going to be correct, but it makes it reproducible and gives a human expert the ability to have a look at it and evaluate it and say, is this a correct step? Has this conclusion, if you want to call it conclusion, been arrived at properly? And I think this is absolutely important for making this technology auditable, make it reproducible, and give a human the ability to validate the outcomes. Because if you would just have a chat interface, you would get one answer. There's no way for you to validate the correctness of this result other than opening a second window and digging for the information yourself. This is the paper, if you want to look it up. It's a modification of the attention mechanism, and I'll promise this linear algebra will not be in the test. Another pretty cool thing about this explainability feature is that it also provides negative context. And what does that mean, negative context? So positive context is how the flow of information, like how do we know certain facts to be true? Where's the source for that? Negative information is there a discrepancy? Do I have information that contradicts with a certain claim? And this is what we've seen here on a report about Wirecard. At the very bottom, we see the statement, while most of the revenues were fabricated, the company below the fake numbers was actually profitable. And this gives us a blue highlight in our playground, linking to the sentence, Wirecard simply seems to have invented the bigger parts of its reported sales and revenues, not having generated any actual profit since at least 2015. And so the technology, the patterns that exist in all these language models that enable them to come up with mostly correct outputs, we are making them visible on the positive and on the negative side. So we can now, in a complex use case, we can show you the information that supports a certain claim, and we can also show you if there's some information that conflicts with a certain claim. And I would argue that we need not only positive but also negative sources to take responsibility as humans. And of course, because we invented multimodality, this also works in multimodal space. So here we have two house numbers, so this is the same picture, and the first claim is the house number is 30, gives you a positive link, and house number is 50, gives you a negative link because it's not 50, it's 30. Although 50 may look somewhat similar. So this is what we need. We need, as humans, we need to navigate through the world of factual observations. And this is also where I see the role of the human in the future. The role of the human in the future will not be basically just kind of typing individual words, but orchestrating knowledge and taking responsibility. So let's look at orchestration. I have three awesome industry use cases. One you may have seen on Hannover Messe. We built this together with HPE on an ABB robot. And sorry, the resolution for this is horrible, but you may still be able to read it. This is where we took a picture of the robot with a smartphone and used the multimodal model to ask questions about this picture. It's like, what's this at the top of the robot? And then the answer comes, signal lamp. And now I can ask a follow-up question. This the steps to perform maintenance on it. And you will see that the contents of this output are highly specialized. This is not something that a general purpose web-based system would be able to answer correctly, but it is something when you connect it to proprietary information, like Marco Buschmann said, right? We need like a specialize the model based on proprietary information in a secure environment, and in this case, this is the technical documentation for this robot. And now I can interact with robots and with systems in a way that is secure and explainable, but it also is correct, even if this information is not on the internet. And we also heard about the land, F13. It's absolutely correct. There's tons of very interesting government initiatives. What I like about this one is that it is very complex, and it's doing things that you would not expect generative AI to be able to do. So it's connected to proprietary knowledge, and it knows the format of internal documents. So we have like pages and pages of Word documents, and you'll see an example. This is these internal documents with like suggestions for knowledge and traces to internal documents. And this is what I like about this example is that, first of all, of course, it's a critical process. It's based on proprietary internal knowledge that's not supposed to be public. And it also is very complex. It has the capability to create documents that support very elaborate, complex internal processes. It's not just a chatbot. And this is also what has piqued a lot of interest on systems and integrations like that from industry and not just from government. Right? But of course, government interest is also high because, yeah, this shows the potential from this technology beyond QA systems or beyond chatbots. The next example is how to build these complex solutions. And this is just like a screen recording of our workflow orchestration engine. So what you usually need to do if you want to solve something like F13 use case is you need to combine different steps. And sometimes these steps use different models. They prompt them differently. So you may use one model to retrieve information. You may use one model to check if it's still relevant. You may use a different model to extract information in a symbolic way. And so every workflow you're doing, every interaction is a combination of steps, conditions, models, data retrieval processes. And this is what you can orchestrate on top of our platform, but there's many others that can do something like that as well. And then you can run against these workloads. And this is also how we're enabling our consulting and integration partners to build and weave awesome use cases without kind of having to touch the model themselves by just combining different models. And of course, you can use our models to do that. You can use open source models. There are some companies that have already came out and announced that they'll be building their own models, which may be a smart thing to do if you're a company that has a lot of valuable data. And of course, you want to combine those models. You want to have them efficient in like batching. You want to maybe have them deployed in your own data center in a cloud environment. You want to combine those deployments. So kind of all these kind of operational sites. And then at this kind of gray layer on top, you have your workloads that are a combination and orchestration of different like generative AI calls and methods. And then you can pipe them into libraries, data sources, systems, and this is kind of, because we're focused so much on large enterprises, this is usually the complexity you just have to deal with. Right? It's never just kind of one web app and then you're done. And and if you're running then, this is the Grafana dashboard from one installation where you see on the very top, the kind of models that are currently online on that environment, the tasks with their typical duration, request times, errors, and the 2,600 is the processed tasks per minute. So these are these workflow orchestration things per minute in this environment. This is a pretty big environment. So this is where we can guide human experts, and we've heard about the lack of experts or the lack of workforce in general. So we need to make sure that the next era of knowledge work and information-based steps will put the human into a different position. No longer grunt work or like manually writing hundreds of pages of document, but taking responsibility. And we need to build technology that empowers the human to take this responsibility. I think explainability is a step there, but it's certainly not the answer to every question. And we need the industry know-how and the expertise and the creativity of all partners, of all companies, big and small, and of course government as well. Because we are on a regular basis, when we are supporting some of our partners, our integration partners and big enterprises, we are usually on a regular basis, we're surprised by with the ingenuity they are using our technology and the technical capabilities to build awesome solutions. So I want to encourage you all to come up with smart ways to use this technology, because this is really just the beginning, and a chatbot is not the next industrial revolution. And there's tons of opportunity based on proprietary data, based on internal innovation, based on creativity and industry know-how. So I want to encourage you to give the new role to the human as the orchestrator and as the person taking responsibility and making sure that the machine is used according to our values. Thanks.